You know, I'm often asked, are there aliens among us? And I'll say that I am one, but...
Or you're from the future.
They don't believe me. We need to be very careful with AI. We need to be very careful with robotics. We don't want to find ourselves in a James Cameron movie.
You're presently building on AI, on robotics, on space, on energy, all at the same time. When you look across those efforts, what do they have in common from an engineering standpoint?
Well, they're all very difficult technology challenges, but the overall goal of my companies is to maximize the future of civilization, like basically maximize the probability that civilization has a great future, and to expand consciousness beyond Earth. So if you take SpaceX, for example, that SpaceX is about advancing rocket technology to the point where we can extend life and consciousness beyond Earth, to the moon, to Mars, eventually to other star systems. And I think we should always view consciousness, life as we know it, as precarious and delicate, because to the best of our knowledge, we don't know of life anywhere else. You know, I'm often asked, are there aliens among us? And I'll say that I am one, but...
Or you're from the future.
They don't believe me.
Okay.
But I think if anyone would know if there are aliens among us, it would be me. We have 9,000 satellites up there, and not once have we had to maneuver around an alien spaceship. So I'm like, I don't know. Bottom line is, I think we need to assume that life and consciousness is extremely rare, and it might only be us. And if that's the case, then we need to do everything possible to ensure that the light of consciousness is not extinguished, because we're effectively, the way I view it is, the image in my mind is of a tiny candle in a vast darkness, a tiny candle of consciousness that could easily go out. And that's why it's important to make life multi-planetary, such that if there is a natural disaster or a man-made disaster on Earth, that consciousness continues. That's the purpose of SpaceX. Tesla is obviously about sustainable technology, and also at this point we've sort of added to our mission sustainable abundance. So with robotics and AI, this is really the path to abundance for all. If you say, you know, people often talk about solving global poverty, or essentially how do we give everyone a very high standard of living. I think the only way to do this is AI and robotics, which doesn't mean that it is without its issues. I mean, we need to be very careful with AI. We need to be very careful with robotics. We don't want to find ourselves in a James Cameron movie, you know, Terminator. He's got great movies, love his movies, but we don't want to be in Terminator, obviously. But if you have ubiquitous AI that is essentially free or close to it, and ubiquitous robotics, then you will have an explosion in the global economy, an expansion in the global economy that is truly beyond all precedent.
In the future that you talk about, the AI models, autonomous machines, rockets, depends on massive increases in compute, massive increases in energy, expensive energy, manufacturing scale. What are the bottlenecks to get there? And then, once again, with all that expenditures, again, how can we make sure that it's broad and not narrow?
I just think the natural thing is it's going to be very broad, because AI companies will seek as many customers as they possibly can, and the cost of AI is already very low, and it's plummeting every year. I mean, the cost of AI is almost meaningfully changing on a month-to-month basis.
There's open models now everywhere. Yeah.
Yes, there's open models. And the open models only lag, they're maybe a year behind
Right.
the sort of closed models. So I think the AI companies will seek as many customers as possible, which means they'll provide AI to the world.
But the cost of getting to there, the compute, the chips, the fab, the powering, that to me, what are the those are huge.
The limiting factor, yeah, I think the limiting factor for AI deployment is fundamentally electrical power.
It's just, right, it's energy.
Yeah. I mean, we're seeing the rate of AI chip production increase exponentially, but the rate of electricity being brought online is
3%, 4% a year,
Yeah.
max.
Yeah. It's clear that we're very soon, maybe even later this year, we'll be producing more chips than we can turn on. But except for China. China's growth in electricity is tremendous.
They're building 100 gigawatts of nuclear as we speak.
Actually, solar is the biggest thing
yeah.
in China. So I believe China's production capacity on solar is 1,500 gigawatts a year, and they're deploying over 1,000 gigawatts a year of solar. Now, for continuous solar load, you divide that by roughly, 4 or 5. Call it that's around 250 gigawatts of steady state power paired with batteries. And that's a very big number. That's half of the average power usage in the US.
Right.
So US power usage on average is 500 gigawatts. Right. China, just in solar, in solar that can provide steady state power, and batteries can do half of the US electricity output per year just with solar. Solar is by far the biggest source of energy. And actually, when you look beyond, or even on Earth, but certainly beyond Earth, the sun rounds up to 100% of all energy. This is an important thing to consider. So the sun is 99.8% of the mass of the solar system. Jupiter is about 0.1%, and everything else is miscellaneous. Now, even if you were to burn Jupiter in a thermonuclear reactor, the amount of energy produced by the sun would still round up to 100%, because Jupiter is only 0.1%. If you teleported 3 more Jupiters into our solar system, and burnt 3 more Jupiters and everything else in the solar system, the sun's energy would still round up to 100%. Mm-hmm. So it's really all about the sun. And that's why one of the things we'll be doing with SpaceX within a few years is launching solar-powered AI satellites.
Right.
Because the space is really the source of immense power, and then you don't need to take up any room on Earth. There's so much room in space, and you can scale to enormous. You can scale to, I think, ultimately hundreds of terawatts a year.